Okay, so I'm going to do an example of of part 9 on the project. And I did an example of this when I was back talking about logarithms for a short time, but we didn't do one like this in the homework. So let's do this one, and you can sort of follow suit as you do your own. To save up for the 10% down payment that you got in question number 9, you're going to open a savings annuity, and you're going to start saving money, putting in these deposits once a month at 2.5% interest compounded monthly. So it says decide how much you can save each month. So this is up to you. You might decide, oh, I'm going to save $200 a month. Or you might decide I'm going to save $100 or whatever it might be. Okay, so you can make up how much you think once you're working, once you're out of school, how much can you save a month? And then we'll see how long it takes for you to save up that down payment. Now, I am going to just pretend that the house that I was going to make a down payment on is a 20% down payment. So I'm going to call it 20% down payment. Now, I told us in the problem that we're going to have 2.5% interest rate. And I'm going to say I can put away $300 a month that I don't have to pay for other things. But you can make up any amount per month that you think that you could make into a savings account for this purpose. So that's up to you. So you might think, oh, well, once I start working, maybe I'll have more money, or I might have less money if I have student loans and have to think about just $100 a month. You can choose how much that you're going to put for a monthly payment. So with that in mind, I'm going to put $20,000 on the left side. That's the amount that I want to eventually get. $300 is my deposit, and I'm going to go ahead and use the draw feature because otherwise this is going to get tedious. And then I'll have 1 plus my R is 0.025. We are making this on a monthly basis, so that will be 12 for K. And here's the weird part. We've not solved for N. N is our unknown here. And K is again 12. Minus 1. And then on the bottom, I still have 0.025 divided by 12. Okay, so first in our calculator, let's put the 1 plus 0.025 to the 12th power. I'm sorry, I think I said to the 12th power when I meant divided by 12. My brain is still at lunch, I think. All right, so this is a pretty big decimal. And my dog is going to give us some feedback in the background. So that gives me 1.0020833, and I have it now to the 12n minus 1. And that's all on top. And then 0.025 divided by 12, it's just the decimal portion. 0.002083333. Now, as I said, we didn't do one of these before. So we will solve this thing in a little bit different way, and you can follow exactly the same procedure with your own numbers. So what I'm going to do first here is I'm going to get rid of this fraction that's on this side by dividing by what I've got down here in the bottom, or multiplying by what I've got in the bottom. So in other words, I'm going to multiply this thing on both sides and on this side. So over here, this will cancel out. So let me see what that is. And it gives me 41.6666. Okay. Did I have this? Now don't try to take some shortcuts here, because I guarantee you if you do, you will not be doing some proper algebra. So follow these steps as you're solving this and you'll get to the right place. Next thing I'm going to do is divide 300 out on both sides. So I'm going to divide 300 out on this side, and of course what I do to one side I got to do to the other side. And over here what's going to happen is 300 will cancel out. And let's put that into our calculator. And I get 0.1388 88866 667. Big long decimal. And now what's left over here is this ugly thing raised to the 12n power minus 1. So my next step is to get the minus 1 to the other side. So we're just going to add 1 to both sides. Over here, the ones will just cancel out, and I'll have 1.1388866667. Now, at this point, I had sort of discussed using logarithms to help us solve equations of this type when we first started this, but then I didn't put any in the homework. And you don't have to worry, I'm not going to throw it to you on the test after we've not practiced it in the homework, but we do have to do it for this one problem. All right, so here's what we do. We can either use the log button or the natural log button. Those have to go in front of whatever we put them in front of. So I'm just going to use the log button. It goes in front of the left side of the equation. And it goes in front of the right side of the equation. Now on the left side, I can go ahead and put this thing into the calculator. I can press the log button and I can enter 1.13888666667 and hit enter, and it gives me a decimal 0.05 0.85. All right, now on the right side though, I can't do that yet. I still have this unknown value right here. But we talked about previously, when I did do an example of a logarithm, that this right here, the exponent, can be pulled out to the front of a logarithm. It has that property for logarithms. So if we do that, we put our 12 in the front. Now that I've got it written like this, the exponent is no longer behind the logarithm, just this number is. I can go ahead and do log of 1.0020833 in my calculator. So I'm going to put that into the calculator. And log of that number gives me 9.038. 37. Oh, okay. I get a number that says, let me erase this. This says 9.038, blah, blah, blah. And then it says E minus 4. And what E minus 4 means is take the decimal back to the left 4 places. So if I do that, I'll have 0.0009038 3755. My dog is determined to help us out. 36. All right, now we're going to clean this side up and then we're going to finish this off. So I'll rewrite this. But what I'm going to do is multiply the 12 times the 0.0009 blah, blah, blah. And I'll leave the n behind it. All right, so 12 times 0.009 gives me 0.01. 0846 0506. And I still have my n. All right, so now let's just finish solving it for n. Let's divide this number out on both sides. And we will have how long it takes for me to save it. Now at this point, I will round off to 1 decimal place once I put this in the calculator. So we'll have an idea of how many years it takes for me to save up this $20,000. So I'm going to have n equals whatever this is. And that, if I round to 1 decimal place, is 5.2 years. Now, when you're done, make sure it's a reasonable amount. If you got 20 years, unless you're putting in a very small amount, 20 years is probably not a very reasonable amount. It should take you just 5 to 7 years or something like that, depending upon how much you decide to pay into your account, if it's 200 or 250. If you put 100 in, it's going to take more time, obviously, than 300 did. And of course, if your down payment is much larger, if it's $50,000, it's going to take you longer to get there for certain.